Hello, everyone. I guess we can still say good morning. Welcome to my session. So today I'm going to talk about RISC-V ready for powering the era of intelligent general computing. So we all know that AI machine learning have been growing like crazy, especially in the hyperscaler data center. But the intelligence also come to general computing. So here I'm going to give a couple examples of intelligent general computing. For example, AI PC, AI phone, that's for personal use, and also AI industrial PC or AI edge server used in factory automation, surveillance, or even things like drone. And there's a software-defined vehicle with covering ADAS from level 0 to level 4, or even autonomous vehicle. So there's a lot of AI machine learning technology used there. And there's also robot as a platform with all kinds of any form. So people are talking about running different apps. Then humanoid can serve as cooking master or kung fu master, or maybe teaching you language or teaching you science. And so features are enabled by app. And as people talking about, it can be much bigger than smartphone we know today. So intelligent computing call for rich ecosystem for general purpose computing, that for sure, and also advanced ecosystem for large scale AI machine learning, both hardware and software. So RISC-V actually being enable innovation in large scale AI machine learning. So let's use Andes customer as example. For example, Meta MTIA have been using Andes RISC-V processor, scalar, vector, and also our automated custom extension tool called ACE to build LP, and they build up the processor array based on that. And we have several other customers on different areas like SRAM-based computing memory, AndesAIRE, Tetraman, Fractal, and so on, and also other customers like Reverse, Sapien, and so on. So they all use kind of mix of those combinations. RISC-V scalar for control, vector for compute, and also AC. Not everyone using everything, but the concept is here. And also, RISC-V software ecosystem is very fast maturing with RVI cooperation with RISE. RISE is a RISC-V software ecosystem, which is a consortium formed to accelerate the development and also raise the quality of open source RISC-V by aligning the effort from all the interesting parties so that you don't need to have the overlap effort. So Andes is part of this founding member for RISE. And RISE had focused on all the fundamental key software components as we list here, like system library, kernel, runtime language, Linux distribution, and so on. So here's a quick example to give an idea of what that means by fast maturing. So Debian regular build over 64K packages. And this is a screenshot I take about 3 months ago. I think the rate is similar. So RISC-V successful build rate is over 94%. It's a rating number 3 behind x86 and ARM. And even x86 is not 100% because sometimes the new update of package will break thing here, there, and need to fix it. And here's another example by Andes customer doing the 5G Open RAN. So their original product is based on the board with ARM-based Qualcomm Cortex-A72 with a couple more smaller chips they designed. In the new generation, they put that into an SoC and replace that with a tool called Andes 45MP. And then based on that, they go out to open source to download like from U-boot and then the Linux kernel and already to build up their Open RAN software ecosystem. They don't need much of Andes help because it's very easy to use. And when they do the DPDK optimization, they come to Andes a little bit regarding how to optimize with Andes processor and their SoC memory subsystem. Okay, so next I want to talk about, give an update on Andes processor. able to help on intelligent general computing. From the left, we have AX46MPV, which is a Cortex A55 level processor, but our spec in is over 5.5 per gigahertz, already over that. And 8-stage pipeline, dual issue, RVA22. So this is the AX40 series. And then we have X60 series, X65. It's a 4-way out-of-order machine, RVA22 plus. Spec in is 8.78. And then that is already released like 2 years ago, but now we are working on AX66 to have about 15% performance boost, but at the same time, we bring it to RVA23, like vector crypto, hypervisor, AI, and so on. And then go to the right, in hard chip, we announced we have next year, even newer performance level, actually 2x of AX66 at Cuzco, which we're going to talk more about it. But in the performance target is 20 spec in per gigahertz when it's configured as 6-way out-of-order processor. So in the following, we're going to talk into detail about those processors. So X46MPV is a powerful compute with a wide vector and also with efficient control. So it can be configured as a just scalar processor if you have your own vector, but it has a quite powerful vector as well. It's a new generation over the 45 MPV. The major change is it can dual issue pretty much all the vector and scalar combination of the instruction. And it's a vector processor, and vector unit can go up to 1024 bits, support all the standard format, including the bfloat 16, which we do a full arithmetic, not just do the conversion of MEC, because that enabled so much easier to adapt their new algorithm. And also we enhance reduction sum, which is very important, because if you speed up the previous computing, at the end you need to do a reduction sum. If that part becomes sequential, then your performance bottleneck will be there. And the most important improvement for 46 MPV over the previous generation is the memory performance. So we support dual issue of low store, too low, two store, or one low, one store, and vector and scalar combination. So any two low store. And we also have very strong capability for low store outstanding and going out to memory, because in the large scale SoC, the control, when the processor uses control, you need to access external memory, and that need to be, usually it can go all the way to DRAM. So it's long latency, you really need a high degree of outstanding to able to overlap the latency. And HVM is very useful for those who use 46 MPV as part of the accelerator to access the shared memory with their, for example, external metric multiplication engine. Since we support dual load, so we have two ports going out from processor, and we implement HVM reference implementation, so it can support all the conflict resolution, and then return the result to the processor. But that result can be out of order, so the processor need to handle out of order return of low result, even though the process itself is in order. So this is very important. Otherwise you either get deadlock, or you need to be very conservative in terms of issuing the request. So here's an update on the performance. So earlier we talked about spec in, it's about 18% over the previous generation, and the actual spec in on the latest data is 5.65 per gigahertz. And the vector library, it's about 2x for some key function, and on average about 20% improvement. Later we're going to talk more about so-called vector-related library. In terms of memory bandwidth, copy, move, and so on, it's about 40%. So next to X66, our mid-range application processor, RVA23 compliant, but it's from the very top level, it's very generic four-way decode out-of-order processor. but well, we adding dual pipe vector with VLAN 128, and it's shared with a 14-point unit, so to conserve the area. And so the other part, like execution pipeline, branch prediction, stage, and so on. So it's pretty common. So I want to update with vector performance because 66 we're adding the vector compared to the previous one, and also kept vector crypto. So compared with the scalar itself, that is you don't use vector instruction. We have NN library. So for the key function, it can go up to over 10x speed up, and on average about 9.6 speed up. And we have also more generic vector library like FFT, filter, statistics, and so on. So for the most of the category, it can reach over 4x improvement with 128 vector, and on average is 3.5. And also for vector crypto, it can get to close to 5 or over 10x speed up on a couple of different crypto function that RISC-V vector crypto ISR support. On the bandwidth part, with vector, can improve like 25% over the without vector. So next, Cuzco is our latest high-end Pekin processor. It's RVA23 compliant. The most important feature here is we call patented time-based scheduling. It comes with a resource, a time resource metric, which is used to determine when after instruction decode and when instruction can be issued, so in the future slot, and also record that information for future issue checking. So it's very different from the traditional one, which means you issue instruction, and then every time there's a new result generated, or your operand need to continue to check to see if that is for you or not. So that can burn raw dynamic power, also introduce logic complexity. So this is quite a new innovation in our time-based scheduling. So Cuzco is the default is 8Y decode, but it can configure into 6Y decode to have a little smaller area, and also the power consumption. So the total has 8 execution pipe, is organized into 2 pipe per slice. So that's why you can easily configure it. So the other microarchitecture part is pretty. So from high level, again, it's very standard, like the latest branch prediction, 2-level TLB, and private cache L1 and L2, and L3 is we call mostly exclusive with L1, L2. So that you don't need to be strictly exclusive, but sometimes for convenience, it can be inclusive with L1, L2. But you maximize the whole your capacity for caching. So it support up to 8 core is a native CHI from L2 all the way to L3. So it's ready for multi-cluster cache coherency. Okay, so Cuzco, we have early implementation at 5 nanometers on CPU part. Execution pipe is 7 million gate, and L2 controller, if you configure to 2 megabyte, is 4.5 million gates. So our target is 2.5 gigahertz. Again, now without using a vector, so our spec 2006 already close to 18 per gigahertz. Okay, so now a little bit about Andes software. So we have AndesAIRE, which means Andes AI runs everywhere. It can take AI model and go through some optimization and generate the underlying RISC-V instruction. We also have its custom extension to can generate supplement files so that users, if they define additional instruction, they can rebuild with LVM, then it recognize all the instruction custom design. And we also optimize quite a few microkernel, and also we have some work on Llama CPP. So we are able to run on the Q4 format and for Tiny Llama, and also Gemma, and also DeepSeek. So with VLAN 512, we can have over like 26 speed up and above, all the way to 30 based on AX46 MPV. So 45 MPV. So 46 MPV should be higher, but we don't have data yet. Right. So in the last is that for general computing, Andes provides software certainly leverage RISC-V RVA 22 standard and also reach Linux distro, but we also provide additional value. That is, for example, our long-term support package, we run it through Linux test project to ensure consistency between our the standard software and our hardware. And we also provide some additional feature, and we upstream to open source so that everyone can share and continue to enhance that. And RTOS, we also has quite rich set for that, for free RTOS, and also Zephyr single core, multi-core, 32 bits, 64 bits, and also commercial RTOS as well. Okay, so in closing, Andes has been leading RISC-V IP shipment because we have a rich portfolio of processor up to over 30 RISC-V processor, and also the software and development tool that we provide. And our latest processor, like 46 MPV, offer the wide vector for power compute and efficient control processing. And AX66 and Cuzco provide a wide range of performance for packaging processing. And now, coupled with the RISC-V ecosystem maturing, I think we can take the so-called emerging intelligent general computing. And I think Andes is well positioned with a combination of our different processors. They say you can use, you need a packaging processor, but you also need wide vector, wide powerful compute to crank out the AI data and so on. So with that, I conclude my talk and just use up 1 minute, 1 second left. Sorry, I probably don't have much time for
So we have time
question.
for one question. Any question?